Hello and welcome to our network data analytics demonstration. This video will show you how to use and configure VPP in the data plane, how to collect runtime statistics from data plane using Ipfix protocol, and also how to store, analyze, and visualize the data with the data analytics platform. All this achieved with just open source software. So let's take a look at our topology. It's a simple topology that consists of two VMs, each running a VPP. Each VPP manages a single interface connected to the same network. This enables the communication between VPPs as well as all the other interfaces within the network. Besides VPP, there is also our Ipfix Collector deployed in VM number 1. It is responsible for collecting Ipfix data from both VPPs, transforming them, and pushing into our data analytics platform. This diagram gives us a closer look of the data analytics platform. It runs in a single VM and all the components run as separate Docker containers. It consists of Kafka for data ingestion, Goblin transferring the data between Kafka and Hadoop distributed file system, Hadoop providing distributed file system, Spark enabling us to run distributed analysis, Spark Notebook providing easy to use interface for Spark, and Hadoop file browser. This platform is very similar to the Panda project. In fact, it's a scaled down version of the Panda platform running in Docker, ideal for development and testing purposes. You can learn more about Panda in this web page. Now it's time to take a look at all this in action. We have the two VPPs with pre-configured interfaces as well as the Ipfix export. On the right side, there's our data analytics platform, not doing much at the moment. So by starting our Ipfix Collector, we tie both ends together. The VPPs representing the data plane and the data analytics platform. As you can see, the Ipfix Collector immediately receives Ipfix information from VPPs and pushes the information into Kafka for our data analytics platform. If we try to ping one of the VPPs, we should see the updates in the data exported to data analytics platform. This is the Hadoop file system browser, and we can check the data coming in from Kafka. Let's open one of these files, and we can see the data records stored inside HDFS. Each of the record provides following information: the timestamp, when the record was created, the IP address of the VPP, the source and destination IP addresses of the connection, the protocol used within that connection, and the total counter of packets transmitted inside a specific connection. Let's check on Spark. It seems to be running without issues, and so is Hadoop, which allows us to proceed to the analytics part. This is a Spark notebook developed to analyze and visualize the data we just seen. So let's start with this. First of all, we just check Spark configuration to verify that everything is okay. Second of all, we load the data for our analysis. And now we can start with something simple, like listing the IP addresses of all VPPs in our topology. As expected, there's just two of them. We can also list all the IP addresses of nodes that our VPPs communicate with. And as you can see, there's a couple of them for each VPP. So let's try something more interesting, like visualizing the overall traffic for a single VPP over time. Let's import the required libraries, calculate the data, and visualize. So this is the graph that shows the overall traffic over time for this VPP. We can see two drops in traffic that can indicate possible network issues or issues with our VPP deployment. We can also distinguish and visualize the traffic for each connection separately. So if we again prepare the data, and draw the graph, we can see a couple more lines, each representing a specific remote node. Another interesting analysis is the ratio of various protocols handled by one of our VPPs. So let's try something like that. And we can see a pie chart representing the ratio of traffic among all the protocols detected. There are three of them: ICMP, TCP, and UDP, with ICMP being the biggest part of our traffic. Lastly, we will try to visualize our topology of VPPs and their connections. So if we prepare the data, we can draw the topology. This is a simple visualization where red dots are our VPPs and blue dots are the remote nodes. The locations on the map are random and were used just for better demonstration. And that's all from our network data analysis node. So this overall was a demonstration of how open source tools can be used both in data plane and in platform for data analytics. It showed an end-to-end simple use case from data plane configuration through data collection up to the analytics part.